Hi friends, in this video we are going to see how we can use 2 wattmeter method to measure 3-phase power in the case of star connected leading power factor load. Leading power factor means it is a capacitive load. Now I am having a star connected leading power factor load connected to a 3-phase supply where phases are R, Y and B. So circuit diagram will be like this. So I will connect 2 wattmeters such a way that in R phase current coil of first wattmeter is connected and second wattmeter is connected such a way that current coil of that wattmeter is in Y phase, and I will have B phase like this. Voltage coil of first wattmeter is connected between R and B. Same way, voltage coil of second wattmeter is connected between Y and B. So this is how we are going to connect wattmeter in the circuit, and to this supply we are connecting a star connected leading power factor load like this. So this is a load having R, Y, B phases, and impedance is ZPH. It's a balanced load, so the impedance magnitude is same and phase angle is also same, and this is a neutral point. Now R and Y, the voltage between them is a line voltage, which I will represent at VRY. Between Y and B, I have VYB, and between B and R, the line voltage is VBR. Let's mark line currents. R phase will carry IR, Y phase IY and B phase IB. Let's go to load side. So the voltage between this R and N is a phase voltage represented as VRN. Between Y and N, I have VYN, and between B and N it is VBN. Same way I will have a phase currents IRN, IYN and IBN. So this is a complete circuit diagram, and this particular part is a wattmeter 1. And this structure is wattmeter 2. Let's list out the things that we have denoted. So here I say VRY, VYB and VBR is nothing but VL, which is line voltage. Then we represented IR, IY, IB nothing but IL, line current. Then we have shown VRN, VYN, VBN, nothing but VPH, phase voltage. And finally we have shown IRN, IYN and IBN, nothing but phase current IPH. And ZPH is a phase impedance. The nature is capacitive or leading power factor. So this is a structure that we will connect while measuring power with the help of two wattmeter in star connected leading power factor load. Let's move to the next part, that is wattmeter readings. I have two wattmeters. So wattmeter 1 and wattmeter 2. What I need to know? I need to know what is the current it is going to measure and what is the voltage that will come across voltage coil of this wattmeter. Same is the case for wattmeter 2. Let's go to circuit diagram. Here I can say current coil of wattmeter 1 is in series with R phase. So obviously it will sense and measure IR. So the current measured by wattmeter 1 is IR. Let's check voltage. Voltage coil is connected between R and B. So it should be VRB. We cannot say VBR because current is entering in this direction. So this will acquire a positive polarity. Hence, voltage measured by voltage coil of wattmeter 1 will be VRB. It is not VBR. So here I will write voltage for wattmeter 1 is VRB. Let's check for wattmeter 2. Current coil of wattmeter 2 is in series with a Y phase, so it will sense and measure IY. So I will write over here current for wattmeter 2 is IY. Let's check voltage. Voltage coil is between Y and B, so the voltage measured is VYB. Now based on this wattmeter 1 reading, I will denote that with W1 will be voltage multiplied by current multiplied by cos of angle between voltage and current measured. So I will represent that like this, VRB angle IR. Same way wattmeter 2 reading will be voltage measured by voltage coil multiplied by current measured by current coil multiplied by cos of angle between VYB and IY. So my job is to find out angle between VRB and IR, VYB and IY. So that angle measurement we can do with the help of Phasor diagram. So not only a wattmeter 1 angle but also wattmeter 2 angle, and that is angle between VYB and IY. So next step is drawing a phasor diagram. So let's start with a phasor diagram. We always start with the phase voltages. So phase voltages are VRN, VYN and VBN. Since it's a balanced system, so the magnitude of voltages are same and angle between them is 120 degree. So first step is this is VRN. Lagging VRN by 120 degree, we have VYN. Leading VRN by 120 degree, we have third phase voltage, that is VBN. Now we know the load given is inductive in nature, so I can say current leads voltage by angle phi. So for a capacitive load, I will have corresponding phase current leading phase voltages by angle phi. So for VRN, the current is IRN leading it by phi. Same way for VYN, it will lead by angle phi, and same is the case for VBN also. So this angle is phi. Now we should know the voltage VRB and voltage VYB. So we know VRB is like this. VRN minus VBN. All these are the phasors. Similarly, VYB is VYN minus VBN. Again, these are also phasors. So my job is to get minus VBN. So equal and opposite to VBN, I will have minus VBN. So I will draw that. Now I can add VRN and minus VBN. Remember, it is a phasor addition. So we need to form a parallelogram. Rather, it is a rhombus. So addition of these two, I will get a voltage VRB. And addition of VYN with minus VBN, I will have VYB. So again, I will add these two. Now remember, IRN is a phase current. For star connected load, this IRN is same as IR, and that is line current. IYN is same as IY, that is once again line current. Same is the case for this IBN. VRN is a phase voltage, but VRB will be a line voltage. Same way, VYB is also line voltage. Why I am marking this? Because we should know VPH and VL Phasor relationship in star connected load. What does that mean? Angle between phase voltage and line voltage is 30 degree. Same I can represent for this. We are interested in knowing the angle between IR and VRB, IY and VYB. So if I see it properly, I will come to know the angle between VRB and IR is nothing but 30 degree plus phi, and angle between VYB and IY is 30 degree minus phi. So we got the angle between VRB, IR and VYB, IY. So we can proceed further for a calculation part. So now I can say wattmeter 1 reading will be nothing but VRB multiplied by IR multiplied by cos of angle between VRB and IR. Remember, VRB is a line voltage, IR is a line current, and angle between them we just now calculated, it is 30 plus phi. I will denote this with equation number 1. Similarly, wattmeter 2 reading is VYB multiplied by IY multiplied by cos of angle between VYB and IY. Equation number 2. Now I will add equation 1 and 2. So I can say this VYB is VL, IY is IL, cos angle between them is 30 minus phi. So let's take this as equation number 2. So I can add equation 1 and 2. I will get W1 plus W2 equal to VL IL. I will take common in bracket, it is cos 30 plus phi plus cos 30 minus phi. So here we are going to use the formula cos C plus cos D, and that is equal to 2 times cos C plus D by 2 into cos C minus D by 2. So if I use this formula, I will get W1 plus W2 as VL IL multiplied by 2 cos 30 plus phi plus 30 minus phi upon 2 into cos 30 minus 5 minus 30 plus 5 upon 2. So I will get cos 30 plus 5 minus 30 plus 5 divided by 2. So if I simplify, I will get W1 plus W2 equal to 2 times VL IL. Here 5 get cancelled, and here 30 get cancelled, and further simplification will give me cos 30 multiplied by cos 5. Cos 30 is root 3 by 2. So if I substitute over here, ultimately I will get W1 plus W2 equal to 2 VL IL root 3 by 2 cos 5. Again 2 get cancelled. So finally I will get W1 plus W2 as root 3 VL IL cos 5. I will consider this as equation number 3. But if you see properly, the formula for 3-phase power is W1 plus W2 is nothing but a P, power consumed. So addition of 2 wattmeters reading will give you power consumed in 3-phase circuit. Let's find out a power factor. For that, we need to do subtraction of equation 1 and 2. So if I do that, I will get W1 minus W2 as VL IL. Once again I will take common. In bracket I will get cos 30 plus 5 minus cos 30 minus 5. Here the formula that we are going to use is cos C minus cos D, and that is nothing but 2 sin C plus D by 2 into sin D minus C by 2. Let's use it. So W1 minus W2 equal to VL IL in bracket 2 sin 30 plus 5 plus 30 minus 5 upon 2 into sin D minus C. So it's 30 minus 5 minus 30 minus 5 upon 2. So here 5 get cancelled, 30 get cancelled from second term, and if you simplify further, I will get W1 minus W2 as 2 VL IL sin 30 multiplied by sin minus 5. Sin minus 5 is nothing but minus sin 5, and sin 30 is 1 by 2. So if I substitute that, I will get W1 minus W2 as minus 2 VL IL 1 by 2 into sin 5. 2 to get cancelled. So finally I will get W1 minus W2 as minus VL IL sin 5, equation number 4. Now with the help of equation 3 and 4, we can get angle phi. How? Let's see. So we will perform this operation. Equation 4 divided by equation 3. So if I do that, I will get W1 minus W2 upon W1 plus W2 equal to minus VL IL sin phi upon root 3 VL IL cos phi. Here I can cancel VL IL, so what I will get is this W1 minus W2 upon W1 plus W2 equal to minus 1 by root 3 sin upon cos is tan, and further simplification will give you phi equal to minus root 3, rather I should say tan phi equal to minus root 3 in bracket W1 minus W2 upon W1 plus W2, and from this phi is nothing but tan inverse of minus root 3 bracket W1 minus W2 upon W1 plus W2. And from this phi I can get power factor of load which is nothing but cos phi. So if you notice, for star connected lagging power factor load, minus sign was not there, but whenever the leading power factor load comes into the picture, the minus sign will appear in the formula. That is the only difference, right? So the difference is occurring because of type of load, but it does not depend upon type of connection. Meaning, for star connection load, if I have lagging, I will not have a minus sign while calculation of phi, but whenever I change load from lagging to leading, minus sign will come into the picture. As far as power is concerned, it is simply addition of two wattmeter readings. Thank you.